Hello, today I have my colleague Daniel Murrmann with me, and we will talk about domain-driven design in the backend, plus RESTful services, real REST or level 3 REST. Hi, Daniel.
Hi, Manfred.
Do you want to introduce yourself a bit?
Yes, thanks. I'm Daniel. I'm a full stack software developer for distributed and cloud native applications. And yeah, as maybe most full stack developers, I have one technology in each layer you need as a full stack developer. And in the front end, it is Angular. Of course, that's why I'm member of Angular Architects. And in the backend, I'm specialized to the .NET technology stack. And for hosting, I prefer the Azure cloud. And that's the world where I'm at home, I would say.
Awesome, awesome. And this really allows us to tell our story also with regards to the server side, because quite often we stop at the client side, but a real architecture, of course, has a lot of parts we need to consider on the server side. Also, when it comes to domain-driven design, domain slicing, strategic design, and so on and so forth. And that's why I'm really looking forward to this interview today.
Yes, exactly. You're completely right. And in our history as Angular architects so far, we were mostly talking about the front end. And yeah, as you said, we try to tell our story until the last end. And the very last end is also not the back end. It is even the hosting, if you ask me.
Hmm, cool. I thought back when we met for the first time, and it was already about 10 years ago. It was at a German company, a huge company, and you've been responsible for a huge project in the area of Industry 4.0.
Yes, exactly. This was the time when I was working as a team and later as a department lead for a larger software development team. I learned a lot in this time, own experiences, but also we together learned a lot. It was the
Mhm.
time of Angular 1. It was
Yeah,
the time of .NET Framework. It was not the time of Azure Cloud, and it was not the time of, yeah, let's say microservices, what we see today in today's backends. So a
yeah,
lot of has changed since this time.
totally. A completely different time. Okay, cool. We agreed on several questions before. Let's get started with a critical question. Namely, you are doing a lot with DDD on the server side and also a lot with RESTful APIs. And my first question is, how do they fit together or do they even fit together?
Yeah, glad you asked this question, Manfred. And yeah, when I was responsible for multiple software teams, and also when I started as a consultant and coach and trainer, I quickly realized that in such larger teams, there is no common understanding, or let's say maybe little at a maximum little common understanding how we design REST services, how we make it good, how we make it repeatable. I have seen REST services caring about small snippets of data. I have seen REST services caring about large, complex data hierarchies. And the question is now, what's the right thing, and how can we make something repeatable so that everyone in the team, and in the best case, each team, if you have a multi-team setup, makes REST services in the same manner. And so I started to think what could be a solution for this. And quickly, domain-driven design jumps to my mind because it is a good approach to model your data. It is a technology-independent approach. And DDD cares not only, but also a lot of data consistency, cutting your data model into smaller parts and all this stuff. And I thought this could be a good approach. And on the other hand, we had REST, and REST is just a, well, let's also call it an architectural pattern for communication. But REST lets everything open when it is about cutting your data model into smaller parts. And then I thought maybe it is a good idea to combine both technologies together. And if you
Mhm.
ask me, if you combine both together, it both both yeah fit perfectly together. And
Cool.
yeah, that's the history of this idea.
Mhm. So to go a bit more into details, how do you use DDD for defining a good API, for modeling a good API?
Yeah, maybe let's have a look at a slide I prepared for this. And here I can explain this on exactly one aggregate. And at first, maybe let's clarify some terms DDD defines. We have one term, this is called the entity. In our case, this is a flight. So I think everybody can imagine what we need for a flight. For a flight, we need a connection. The flight has needs to go from one location to a different location. Maybe we have additional data like international airport codes or something like this. We have times, so maybe we have a flight with the same connection, but this connection is used at different times. And what we also need maybe is an operator. Maybe we can have the same connection with the same operator at different times, or the same connection with this at the same time with different operators. So those are the things which make up a flight, and those things, the connection, the times, and operator is called a value object in DDD. DDD tries to make things as explicit as possible. You can design your value objects very small, very granular. You can also make it a little bit more, or you can also package multiple properties together. So this is up to you, but you should have a look on the coupling. The more tighter properties or data is coupled, the more it speaks for putting all of this into the same value object. Yeah, and usually if I change something at the times, maybe the arrival, then also, or if I change the let's say, also if I change the take of time, then also the arrival time needs to change. So this is typically, this means I have to change both properties, takeoff and arrival, at the same time. And this means they have a stronger coupling as, let's say, the takeoff time and the destination location. This is something different. And this is the idea from DDD with the entity and the value objects. And all this together is called an aggregate. And DDD defines that an aggregate needs to keep its consistency. And we can only keep consistency on the level of an aggregate, not on the level of an entity, and also not on the level of a connection. For instance, if we calculate the times depending on the connection, then this is only possible if we have the connection and the times object. Otherwise, it is not possible. And what also is defined by DDD is that an entity, in our case the flight, has a conceptual identity, which means we don't make primary keys out of multiple properties like we have learned this maybe in very classical relational database design. We need one single value which uniquely identifies such an entity. And this could be an ID, which is incremented by database. It could be a GUID, it could be a hash or something similar. But it is important that it is one single ID. Yeah, and if you look at such an aggregate, then the idea is what I would like to propose to create a new aggregate means sending such an aggregate to a URL, and this URL ends typically with the name of this aggregate or the plural of the name of this aggregate, in this case flights. And I use the post method, the post HTTP method, to send such an aggregate here. And to read such an aggregate, we use the unique ID and append it to the same URL and use the get verb. And this is the way how we can read the entire aggregate. To update such a value object, we use again a URL which is extended after the unique ID of the aggregate. We extend it with the name of the value object. And we do this with each value object, with the connection, with times, and with the operator. And to delete such an aggregate, we use the same URL as in the case of reading the aggregate, but this time with the delete HTTP verb. And what I say now is that we always have data which is read-only, and the most important read-only data is the unique ID of the entity of the flight, and this is something we should never write, and that's the reason why there will never be a put or a post on the aggregate level. Sorry, on the post, we have for creating a post, of course, on aggregate level, but we will never, after this, change something on the aggregate level. We only change the value objects. And then we have also a place for read-only data. We can put all other read-only data, calculated fields or other stuff we have on the entity level, because this will never be touched by the API. And yeah, this is something I've written here on the bottom left on this slide, that yeah, an aggregate, updating on the aggregate directly is something we shouldn't do. And with this approach, with this logic, everybody in the team should be able to design REST services for aggregates in the same way, repeatable, also across teams. And this is something, yeah, which makes also an API very universal. So you don't need to think a lot about the client. With this approach, you design a very universal API, which could be used by a front end, but also by a different back end or other clients.
Cool. I haven't told you before, but I've tried this out several times since we discussed this for the first time, and I really love it. It takes away several burdens from me. One burden it takes away from me is I don't have to think all the times how to extend the API. I don't have to decide whether I start with the root of the URL or if I append a new part of the API to an existing URL, because this gives me some hold. And another advantage of all of this, in my opinion, was that I don't have an issue with updating complex data structures because all the parts of this aggregate are updated separately. This really helped me, so I really like it.
Thanks for this great feedback, Manfred.
Pleasure, pleasure. So let's move over to the next question we have prepared. It is about REST. More or less everyone knows about REST nowadays, but you are specifically talking about REST level 3. So what can we assume when we hear REST level 3?
Yes, exactly. Another favorite topic of mine. I'm a big advocate for level 3 REST services. And also let me pick up our audience here, what it is about. It refers to a REST maturity model created by Leonard Richardson and also supported by Martin Fowler, our, yeah, I would say biggest software guru in the world. At least some see this as I. And yeah, he created a maturity model with which you can assess your REST APIs and can, yeah, order them into a order of maturities. And here he says that a really RESTful, a truly RESTful service needs to make use of hypermedia. And if you do this, then you can easily implement an advanced concept, which is called HTEOAS. And HTEOAS stands for Hypermedia as Engine of Application State. And with this, we can transport much more information from backend to client, as with just, let's say, the typical JSON objects, which make up only the payload. We can transfer much more. I can quickly show you this maturity model. Okay, so this is the slide on which I summarized the different levels created by Leonard Richardson. And what we are talking about is the last one, level 3. And yeah, what he is stating here is, as I mentioned, use different URLs. That's one of the most important things. Address your data uniquely. For each individual data, you should have a unique URL, and you should retrieve this data using hypermedia. And hypermedia means the data has attached some metadata, making more detailed descriptions about the data, about the payload you're asking for, and of course use the right HTTP verbs. So don't make something like RPC over REST or RPC over HTTP, what some people do. They form a URL which ends with a, let's say, a word, something like get user, and have then the parameters at the end. So this is something which we call REST over API or RPC REST, as Leonard calls this here in level 1. What we want to do is to create URLs to data and use the right verbs and retrieve this data using hypermedia. That's the idea behind level 3 REST services.
So if we talk about hypermedia, what could this be? Hypermedia means we have hyperlinks. That means when I'm requesting a flight, I'm getting my flight entity plus hyperlinks to what?
Yeah, hyperlinks. Imagine if you're on a web page and or you are looking for a flight, then maybe you could imagine there's a button flight details, and this button flight details brings you to a different view where you have more detailed information about this flight. And that's the thing we try to realize with hypermedia. And now everyone says, yes, of course, with HTML this is possible, but how should I do this in JSON? And I can tell you it is possible in JSON the same way as in HTML.
Awesome. And what's the advantage of this style?
Yeah, the advantage of this is, I have summarized this on the next slide here. The advantage is that if you have your URLs, your links embedded into your data you're retrieving from the server, then the first thing what you don't need to do is you need not to maintain a list of URLs in your client. I have seen Angular clients with hundreds of URLs where they store URLs in constants with a name schema, where they try to remember what URL they need to call in which case and all this stuff. And this is something you don't need anymore because the URLs you get automatically with a request. The client needs to read the URLs from the response from the server. And yeah, that's, I would say, a lot of effort you save on the client side. And the next thing is, if you properly work with the HTTP verbs and if you have good metadata embedded into your server responses, then the client needs no or at least less domain knowledge. And this makes the client what a client should be. In my point of view, a client should care about visualizing the data. It should care about a great user experience. But in typical, I would say, collaboration systems, enterprise systems, a client should not care about domain logic and domain knowledge. This is something which I see more on the server side. If you make this also in a good way, then you have typically a stateless client, a completely stateless client, because the browser session holds no state information. We don't have something like services which remember that a user inputted something there or something there, and then I need to enable this option or need to disable this option. All this is told to the client by the backend via the metadata. And yeah, with this means also that you can stop on one browser, you can proceed on a different browser, you can send a URL, a link from one device to a different and see the very same view with the very same data. Yeah, it is just stateless. The entire client becomes completely stateless, and stateless is always a good thing when it is about management of large applications. Yeah, you can refactor your backend without a need to change something in the front end, because of course, if you change the URL of an API, then with the next response, the client just gets a different URL embedded into the hypermedia document, and this makes you free. This makes a decoupling between backend and front end. And yeah, if the client really interprets the metadata in a very good way, then the server can change the behavior, or it can at least influence the behavior of a client. Because if a link is missing, then this tells the client that either the user is not allowed to navigate to this data, or the data does not exist at all. And if the client does not see a link, then it shouldn't offer the navigation option, for example. And typically, this is data which you need to send to the client somehow at all. And why not embedding this also directly into the metadata of your payload?
Mm-hmm. Cool. So if I get it right, we need to have metadata, otherwise it's not officially REST. Is that right?
At least according to Leonard Richardson. So there are different, I would say, positions outside in the community. If we go one slide back and look at level 2, then level 2 is the very same thing like level 3, just without hypermedia. We have unique URLs for unique data, and we use the HTTP verbs in a proper way. Then some people also tell that this is a good REST implementation. Others state that only hypermedia is truly REST. So it is up to the listener, I would say, which definition is the one he prefers.
Mm-hmm. Okay. Cool. So what do we have else? Well, now we have seen a lot of concepts which really help us because they give us hold when implementing something, also when architecting something. But as a programmer, and I think at the end of the day, we are all programmers, I want to know how does this look like in the source code on both sides, on the client side and on the server side. Can you show us something about
Yes,
this?
of course, I can show you something. I have also something preferred for this question. So maybe at first, let's look at how everything looks. And here you see a small flight management system, and here you can search for flights. And I have some flights here in the system. Let's maybe take one, Hamburg, München. And I can search for this flight, and of course I only see this one flight. And what I mean now is with stateless, I can just take this URL, open another browser, and let's use an incognito tab and paste the same URL here. And then you see exactly the same state as in the other browser window. So this is the thing I just realized. And to go a little bit faster, you see here for each flight, this is a flight summary card. I have an edit button, and this brings me to an edit page where I can edit the connection, the times, the operator, and below also the price additionally. Yeah, and let's look how this looks from an API perspective. For this, let's open the Swagger view of this API behind this view. And here we have our API for searching flights. So you see I designed a little bit a different API here. This is an API, not a universal API, as we have talked before. This is an API specialized for a view in a web application, in my case, mostly a Angular application. So, and I'm also an advocate and saying someone who says that it is the best thing if you can fill, at least initially, your view with a single request. And that's why, especially for Angular clients, I design a API per view. And this is now from our flights module in our Angular application, the search view. So let's look what I get if I search for flights. Of course, I get an object, and this object has some additional data now. Here you see here the data from the form, which is now not filled because I have no inputs. And then we have an array of flights. And here in the slides, you see in the first slide a link, and this is now metadata. It is, I would say, a common understanding in the community in the area of JSON and JavaScript to prefix private items with an underscore. And that's why I have here underscore links, and I have one link which brings me to the flight edit view model. If you remember, I had a flight search, and from the flight search, I was able to navigate to the flight edit page, and I want to have one request to initially fill each view, and that's my view model, and that's the reason why I'm offering the client, if he searches for flights, for each flight, a flight edit view model, and I tell him you get the flight edit view model for this flight. You see here, this is the flight with ID1, and the ID1 is now here part of this URL, and the client can retrieve the data for this flight from this URL. Yeah, and that's how I can navigate. And this creates me a graph which has an undirected graph with a lot of nodes and connections between the nodes, and there I can navigate through. Maybe let's have another look at the flight edit page. So this is the URL which gives me the view model for flight edit. And if we click on this and now take the same flight with ID number 1, let's see what we get here. We have here again a JSON object. Now you see the value objects I talked about, the connection, and here the connection has some typical values we could imagine from and to, and also the ICAO codes, those are the international airport codes. And here I have no link, so I cannot navigate to something else, especially from this value object, but I have an action. And this action is called update. I can update this connection. And to update this connection, I have to send this object here, this connection object, this one, to this URL. And here you see again, it is about the flight with the ID number 1. And here we would like to address the connection value object. And how do I send it? I have to send it with a put HTTP verb. Also, this is given me via the backend. And so
it's pretty much self-explaining, isn't it?
Yes, exactly. And this is also a good thing for developers. If you have very divided teams where one team is responsible only for the backend and the other team is responsible only for the front end, the backend team can give the front end team a very good hints on how they can navigate through the API. What are the next options? What are the next possibilities? What data can they retrieve from this point on? And that's metadata is always helpful. Exactly.
Nice.
Okay, and that's what the server delivers to the client, links and actions. And this makes up more state information in regards to where can I go to and what can I do with my data. Okay, cool. And maybe finally, I think you also asked for the client. How does it look at the client? Maybe
that would be awesome, yeah.
Let's have a look directly into the code. And here I already created a breakpoint at the position where such a value object is updated. And let's now just start the debugger. We need port 4201. Okay. Let's quickly start it with the debugger and see how such an object looks for the client. So I'm just searching for a flight. I'm navigating to the edit page, and now I'm just pressing save on the connection. And now we have here the view model, and the view model is now here in this case, on this position, just the value object, the connection value object. You see again the properties, and you see that we have our private or metadata underscore actions. Here in the actions, you see exactly what the data the server delivered, the method and the link where to send this object to. And what you can do now is you can generalize. You can do a lot of you can solve a lot of problems with general solutions. And in this case, everyone who is imagining that now I need to read this URL, take the HTTP client from Angular, read the method, and put this object, this HTTP client, to this endpoint, I can say this is something you can generalize because it is again and again the same thing. And so I developed a library, and this library is called HTOS client. Instead of HTTP client from Angular. And this HTOS client embeds you functions into this object. And that's the reason why you see here an update function. And an update function does exactly what I just explained. It takes this object, sends with the method in the action, which is stated in the action, to the URL, which is also stated in the action. If I have a save, if I would have an additional save meta action here, then I would get a save function. And it just takes this object and does all this for you. And this function gets automatically generated each time you retrieve data from the backend. And then all you have to do in your client is to say view model, and you call the update method. You get a promise back, which tells you if the communication was successful or not, and then you can react in your application and just show a success or a error message as I do it here in this example. So very easy, no API no URL handling anymore, very self-explaining. And let me maybe show you a other different example. Let's say I do not have the rights to edit a flight. Then this is the place here where I'm adding all the metadata, the update metadata. And now let me just comment in this line of code, and you see I'm checking here if I'm in a specific role, if I'm in the role, if my token gets here. The application now here makes a look into the token and looks if I'm in the role of the update group or an update role. And now let's start the application again. And I can tell you currently in my case, I'm not in the role. I'm not in the update role. And now I'm not getting those actions. So, and let's get the data again. Let's get again the view model for the edit view, and then you see I get no actions anymore. And what I can do with this information on the client side is, and let's have a look at this flight connection card. And this flight connection card here has a button, the save button we just clicked. And what I do here is, if I don't have this update method or this update function available in my value object, then I'm just not showing the button. And this is exactly what you will see now on the client side. If I'm navigating to such a flight, the buttons are not available or not visible anymore because I don't have the action. This is what I mean. The client now needs to look at this hypermedia. It needs to interpret this hypermedia. And if you have a good implementation on your backend, then the client only does what the backend says, and this makes the client much more independent from the backend.
Cool. That's a really nice example. So thanks for this. And also this client really looks nice because it automates so many things we needed to do by hand otherwise.
Yes, exactly.
Okay, we have another question prepared. It's about a trend. There is a current trend. It's called the API gateway. Some people talk about backend for frontends, which could be the same. It does not necessarily need to be the same, but what's about this? What is the idea behind those concepts?
Yeah, exactly. And if someone was careful listening, then he recognized that I already talked about two different APIs. One universal API created with the domain-driven design approach, And now I just mentioned that I'm a big fan of creating a single API for a single view in our Angular clients, or it's speaking generally in our front ends, so that we can initially fill a view with one request. This often makes the best user experience. And the question is now, if I have universal APIs implemented in microservices and want to have merged the data for the client, who is doing this best? And I think it is best done on the backend side, because the distances between, let's say, the microservices are much shorter. The payload can be bigger. I don't have to care a lot about the payload compared to if I send all universal data from microservices to the front end. And that's the reason why I typically implement a API gateway. And to visualize this a little bit more, I also have one slide here. And I try to visualize this a little bit. Typically on the back end, we have multiple microservices and we have a UI at the front end. And in some cases, maybe it is okay if the UI talks with multiple microservices. But I learned in the most cases, it is better to have such an API gateway. An API gateway which is responsible for delivering optimized responses for the client. So if I have a view for flight search, then the API gateway needs to know which data is needed by the client, and then the responsibility of the API gateway is that it retrieves the data which is needed from different microservices, joins the data together, brings it into a structure which is usable by the client, so that the client does not have to do too much data merging, joining stuff anymore. And some call this also BFF as acronym for backend for front end. I still prefer the term API gateway, but in general, both terms mean the same. And this is not the only job you can give this new box, this new microservice, we can also call it on the backend. You can also have different tasks which this gateway can fulfill. Another one is, for example, it can be the point of your SSL termination. If everything behind the API gateway is in a very secure, in a closed environment, so if you're talking about a microservice application, maybe running on a Kubernetes cluster, then this is the case. If you're talking about a very distributed application, which is running on different hosts in a factory or something like this, then this is of course not the case. But if everything behind your gateway is in a secured environment, then you can use the API gateway also as a point where you make your SSL termination. And behind the API gateway, you only use HTTP anymore and no SSL. And this saves you a lot of processor cycles, because encryption needs power, and power needs money. No matter if on-premise or in the cloud, you have to pay for it. Another point is telemetry. API gateway is a very good point to gather telemetry about the usage of your entire application, which views are requested, how often, and with which data, with which IDs of objects, and all the stuff you can get out of there. And maybe you can also implement your authentication, so to check the token. And sometimes you can also implement authorization, so to decide if someone is allowed to get this data or to call this API or not. In some cases, it is also possible that we need to shift authorization one step farther into the backend on the microservices side, but this depends on the use case.
Nice, nice. So that means because of this API gateway, I just need to do one GET call, and I get everything I need now for this new use case we've just started. Is that?
Yes, exactly.
Nice, nice. I like this idea. Okay, so the thing is, you are doing a workshop on all those topics, and perhaps we can also talk a bit about this workshop, what people will learn. and what's the goal of this workshop. Perhaps we start with the goal. What would you
Yeah.
say? What is the goal someone should have when attending the workshop?
Yes. Let's have a look at this slide again and let's read the title. And the title states goal in a picture.
Ah,
This is the goal of our workshop. This is what we are going to build in this 3-day workshop. I can tell you we are starting really from Greenfield. We are starting with a first microservice. It is about a little flight management system as the one or the other might already expect or imagine. And the goal is to set up exactly this solution. But it is focused on the backend side, so I'm bringing the UI. We are only implementing parts of the UI. In fact, we are only implementing the connection of the user interface to the API gateway. Everything else is already ready out of the box, and we are implementing the entire backend side. We start here with a microservice in ASP.NET Core, and we are learning the fundamentals of the ASP.NET Core Web API framework. We then attaching a database via Entity Framework Core to this microservice. We are learning about the basics of Entity Framework Core. And after this, we are starting with more advanced concepts. We are talking about microservice to microservice communication. We are talking about API gateways. We are talking about HTOS, of course, as an alternative way as for a state management solution. So I see a lot of people outside which are not completely happy with things like NGRX as a state management solution. Especially in enterprises, people always ask to have all the business logic, all the management on the backend side as they are used to from the old projects. And then HTOS can be a solution. And besides the request-response communication, then we finally talk about asynchronous communication. And here we have a look at the WebSockets protocol and between the API gateway and the client. And on the back end, we are talking about message queuing. And for this, we're using RabbitMQ in our example. Yeah, and finally, we are using Keycloak as a authentication solution. And so we have a full demo of a microservice environment with clients and with different aspects. And you can use this as an idea how you can implement your own applications.
wow. Really nice. And at the end, I think you not only have an application, but also an idea of a sound modern architecture that can help you to think a huge enterprise software.
Yes, exactly.
I think you run all this stuff in Docker, is that right? So we also learn a bit about Docker.
Yes, at the end, if we still have some time left, then I'm showing also how we can Dockerize this entire system landscape, because typically the next step would be to go into the cloud with this. And then it doesn't matter if you would like to go to AWS or to Azure or to Google or whatever. Docker is the way to go.
Okay, cool. So who is the target group? What should people already know when they attend this training?
Yeah, the target group is, I would say, everyone who is seeking for advanced concepts in the area of a full stack environment, in the area of microservice environments. And as I said, we start with a very simple first microservice where we are learning the basic concepts about ASP.NET Core Web API and Entity Framework. So the first day is some kind of a ramp-up day for the ones who have basic C# knowledge, which is needed for this workshop. And for the ones who already know about ASP.NET Core Web API and Entity Framework, it is the chance to discuss or ask more in-depth or detailed questions about these frameworks. And then on the second and third day, we are caring only about the advanced concepts we mentioned here on this slide.
Awesome.
And maybe we should also mention a little bit Angular knowledge is also not the baddest. because as I mentioned, you don't implement a Angular client in this application, but at least the connection from an Angular client to an API gateway. And then it is useful if you at least know what an Angular is a component, what is a module, what is a service. So let's say the basic Angular artifacts, if you know about this, then this is at least good for your understanding. Not necessary. I already had people in this workshop which have completely no Angular knowledge. You can follow the guidelines, and then you also can realize all the exercises we have. But yeah, a little bit Angular knowledge is also good.
Mhm. That means if I know how to write a simple CRUD application with Angular, how to do a bit with .NET, then I should be covered for this workshop.
Yes, exactly. Then you get a lot out of this workshop, and yeah, see a path how you can implement more complex solutions.
Awesome. Cool. Yeah, great. That all looks good. So if you are interested into this, then just book a ticket for this workshop. You find everything on our website. And to you, Daniel, thanks for your time. Thanks for this awesome interview. And yeah, see you all at the workshop.
See you, Manfred. Bye bye.
Bye bye.